Hi, welcome to my session and thank you so much for joining. I am extremely excited to have all of you here today. My name is Ngesa Marvin. I am an electrical engineer who is very passionate about Internet of Things, cloud, and developer advocacy. Today, I'm going to show you how to build connected fridges with Azure IoT. I am currently an Internet of Things solutions engineer with Liquid Telecom, and day to day, I get my hands dirty on real projects with real clients. I help engineers and developers to onboard their devices to the network and do cloud to cloud integrations. I also travel across the country to do installations. And when I do so, mostly on Fridays, I love to take nyama choma for lunch. Nyama choma is roasted meat, but the taste and quality of this food stuff is normally different. In fact, the industry is losing customers and revenue. Also, Liquid Telecom, the company that I work for, is in fact an official Microsoft Cloud Solutions provider, and most of the POCs and demos that we do are on Azure IoT. And so today, I'm going to show you how I have used Microsoft technology to build a connected fridge solution so that the food stuff that we eat are safe. I'm going to take you through the Azure IoT services, architecture, and do a demo of the solution. I'm also going to show you why you can get resources about Azure IoT that you can use to do this demo or solve other challenges. You can think of IoT as a three-legged stool where on one side you have an edge device that collects data from the environment and then sends it to the cloud. The edge device is one leg of the stool and the cloud is the other. There are times where you have several devices that should send data to the cloud, and therefore you use a gateway. The gateway is a third leg. Azure IoT enables you to connect any device, including existing devices, and scale efficiently. On the insights part of it, it enables you to analyze the data, set up rules, and act on it. You will also be able to set up visualization and dashboard. Azure IoT also enables you to go beyond just seeing the data visualized or analyzed, but enables developers to be able to integrate the solution into business processes and transform it. And this is how the general coaching solution is going to look like. An IoT device inside a fridge is going to read temperature and humidity data and whisper it to the network. The network is going to listen to the messages and send them to Azure Cloud via Azure IoT Hub. When building an end-to-end Azure IoT solution, there are three paths that you can take: the hot path, the warm path, or the cold path. The idea is to have the right service configured to connect to one another. Of course, the device will have to read data and it will use IoT Hub as a gate to send the data to Azure Cloud. If you have several devices, you can use the device provisioning service. Our solution needs the data to be available immediately from the device for reporting and visualization. And therefore, we will use the warm path where we have the IoT Hub, Azure Functions, and Cosmos DB. Let me take you through them one by one. IoT Hub is a managed service hosted in the cloud that acts as a central message hub for bidirectional communication between your IoT device and cloud. It enables you to connect up to 10 million devices with a protocol of your choice. You can decide to use HTTPS, AMQPS, or MQTT. In fact, we are going to use HTTPS in our solution. With all these, the device will be able to send telemetry, metadata, and even receive command from the cloud. IoT also enables you to manage configurations and update the device. And this is very important to our solution. Azure IoT Hub enables highly secure and reliable communication between your IoT device and cloud. And if you want to register and connect a large set of devices, you could use IoT Hub device provisioning service. You can think of Azure Functions as a serverless event-driven architecture that allows you to deploy your code to the cloud without worrying about the infrastructure. And when I talk about serverless, I literally mean working with less servers. In fact, running your code without worrying about deploying and managing servers. And when request increases, Azure function meets the demand with as many resources as necessary. As requests fall, any extra resource are scaled down automatically. And as it scales, you only pay for what you use. Azure function can listen to triggers as well, ideally the messages that are coming from the IoT device via the IoT hub. We're going to use Azure functions to process and manage our payload, ideally decode the messages that we're getting from the device. And you can easily add bindings to Azure services. The message that was decoded can be saved into Cosmos DB by binding Azure functions with Cosmos DB. And you can think of Azure Cosmos DB as a globally distributed, fully managed multi-model database as a service by Microsoft. It is a Ring 0 Azure service, meaning that it's available in every Azure region. You can add Azure locations to your database anywhere across the world at any time with a single click. Cosmos DB will seamlessly replicate your data and make it highly available. It allows engineers and developers to be able to read and write data in multiple ways on top of operating on top of Microsoft infrastructure. Cosmos DB also allows you to scale throughput and storage elastically, independently, and globally. Meaning that sometimes you can have an app that needs a lot of throughput for notification, and that notifies all the users all at once, but does not require a lot of storage. Or you can have an application that needs to store a lot of data, and you do not want to pay for a lot of throughput. In Cosmos DB, throughput and storage are completely independent, and you only pay for what you need. It also has financially backed SLAs with millisecond latency that guarantees throughput and consistency. Data in Cosmos DB is represented in multiple data models, from key value pair to column family to document and even graph. And all these are exposed by the APIs that are above it. Table API essentially covers the key value data model. Cassandra API covers the column family data model. SQL and MongoDB API covers the document model. And the Graph API is covered by Gremlin. SQL is the default API, and we will be using it in this project. The most amazing thing about all these is that the APIs are interoperable, meaning that you can write the data with one of them and read the data with another. For example, you can write data with SQL and read it with Gremlin in the form of graph. So when you provision an Azure Cosmos DB, the very first thing that you will be presented with is an account, which is ideally a URL and an endpoint for connecting your client applications to Cosmos DB. And setting it up is very simple. You just go to Azure portal, search for database, select Cosmos DB, give it a name, choose an API, and follow the instructions. And you will be up and running in no time. Once you have your account provisioned, you can then go and provision a database. And a database will have a set of containers, and the containers will store your data. The data in the containers will be projected differently depending on the different data models. If you are using a table API, of course it will be a table. And if you're using a SQL, it will be a document. You can generate cool data visualization with your Cosmos DB data and have the familiar Jupyter Notebook experience to do data exploration, data cleaning, and even machine learning. With machine learning, we can predict when the food stuff is going to go bad and help these companies to avoid profit loss and wastage of food. And that's exactly the reason we have selected Cosmos DB to build our solution. I'm going to show you a live demo with this Kenyan-made dev kit, which we designed with a Kenyan startup called Warefab. It runs on STM32, but there are also other variants that runs on other MCUs. It has several inbuilt sensors such as temperature, humidity, and accelerometer. It also has Sigfox, a low power wide area network that will allow us to connect and send the data from the fridge to Azure IoT Hub. I'm going to show you a demo with this device. There is a way that the payload that is being sent to the cloud is normally packaged, and it is only the manufacturer who knows the structure and format of the payload because they're the ones who writes the firmware. You can see that the temperature and humidity information are on the 10th and 11th byte of the 12th byte payload. We will use this guide from WareFab to write a JavaScript decoder that can pass the message. The decoder will then be implemented with Azure functions. So this is how our end-to-end fridge solution is going to leverage on Azure IoT architecture. The device is going to collect data and whisper it to the network all the way to Azure IoT Hub. Azure IoT Hub is going to trigger Azure functions, which is going to manage the payload. The decoded data is then going to be sent to Azure Cosmos DB. So let me show you really quick how the cold chain solution leverages on the warm path in Azure. On the edge, I have a Kenyan-made dev kit that is going to collect temperature and humidity data from this fridge and take it all the way to the cloud via Azure IoT Hub. I also have an off-the-shelf device that can do a similar thing. Let me show you how the data looks like in the cloud. I have taken the primary connection string from Azure IoT Hub and added it to the Sigfox backend so that when we receive the message from the device, this JSON is going to be forwarded to Azure Functions. Azure Functions is going to manage the payload and then forward it to Azure Cosmos DB. In Azure Functions, the message is going to be decoded so that we are able to get the temperature and humidity information, and then it's going to be binded to Cosmos DB. In Cosmos DB, we're going to be able to see the items and be able to have the familiar Jupyter Notebook experience to do machine learning. With this knowledge, you can go beyond building a connected fridge solution. You can help water metering authorities to be able to remotely read consumption data from water meters from different households. You could also help the Ministry of Health to be able to track conditions of vaccines as they're being distributed. You can even help manufacturers know the conditions of the generators by collecting vibration data, analyzing it, and even implementing a predictive maintenance solution in their factory. All these are photos I took of some of the projects I have been working on. The challenges that you can solve with Azure IoT are endless. You just have to look around you. Think about the things you can do for people who are less fortunate. What will you make? You can check out my Medium account at Ngesa254 if you want to learn more about the Kenyan-made WareFab Dev Kit. You can also check out Azure IoT and get started with Azure IoT Hub on Microsoft Learn. You can also get more details about Azure functions on the docs together with Cosmos DB. And if you want to explore the Azure portal, you can go to that link. Join the IoT Tech community to get more news and announcement about Azure IoT. And you can also watch demos, tech talks, and deep dives on the IoT show. Thank you so much for listening to me. And in case you have any questions, please feel free to ping me on Twitter at Ngesa254.